Last time we were talking about decimals, we were looking at the flat as our whole. And you could think about also money, right? So the flat was 100, kind of like a dollar bill, has 100 pennies in it. And then the long was like a dime because it had 10 cubes in it, which would be like 10 cents, or the penny, just a plain old cube. And we remember you could think of these in terms of decimals too. This long was 1/10 of the flat, and this penny, sorry, the cube was 1/100th of the flat, or 100th of the flat. So let's look up again, just so we clearly know at the top here, these place values, when you're talking about after the decimal, the first place value says the tenths, and the second says the hundredths. So if I were reading this, I'd read the whole number, 45 and 64 hundredths. Well, here's the twist today. Now, a meter stick is our whole. Before a flat was our whole, now I want you to be thinking about a meter stick. And sorry, this picture was the best I could do. I can't show you a full meter stick, but maybe you've seen one before, and you would know that a meter stick has 100 centimeters on it. 100 centimeters on it. And then if we zoomed in on part of the meter stick, like from here to here, this is showing us just 10 of those centimeters. And then we could break it up even smaller. Within each one of those individual centimeters are 10 millimeters. So my first question for you are, how many longs, or 10 centimeter portions, are in one full meter? So again, sorry, I don't have a real meter stick to show you, but if you were picturing, we're trying to get all the way up to 100, and we're counting. We'd have 10, then 20, 30. You're starting to see it. I'm trying to do these equally. How many would fit in here? It would take 10, right? 10 tens to get to 100. So we'll answer that question. 10 longs, or 10 10-centimeter units. And then how many cubes, or 1 centimeter units, are in a meter? Well, I told you that already. I told you that there are 100 centimeters, or we're calling them cubes here because we're still using that comparison to the flats and the longs. So in that sense, we know that each individual centimeter is 1/100th of a meter, right? 1 centimeter would be 1/100th of a meter, whereas 10 centimeters is 1/10 of a meter. Okay, keep that in mind as we move into this chart, where we think about the fraction version and the decimals. Oh, we were just doing this. Perfect. So every 10 centimeters we said was 1/10 of a meter, which we could write as a decimal. You're getting good at knowing where to put that in your, after one place after the decimal is the 10th place, so that's where we put our 1/10. And then 1 centimeter we said was 1/100th. So we'd write that. Don't get tricked. Remember the promise you made to never mix up your tenths and your hundredths. We have to put a 1 in the hundredths place. Okay, this is the column I want you to really focus on, because today you will be using your understanding of decimal place value to go between meters and centimeters. So let's take a look at this chart, which is on page 95 in your math journal. So I'll give you a moment to get there to page 95 in your math journal. And in the directions say, fill in the missing information, put longs and cubes end to end on a meter stick to help you. So they actually wanted you to physically move these onto meter sticks and you don't have your meter stick or your longs or your cubes at home, we can talk about it together, and you can visualize laying out a long, or 10 centimeters, or laying out a cube, which would just be 1 centimeter. You can have that picture in your head, and I know we can do this. So if I had 0 longs but 3 cubes, that would mean I just had 3 centimeters, right? You could picture 3 little cubes are just 3 centimeters. But now in terms of a meter, remember we just said each centimeter is 1/100th of a meter, so we'd have to write that as only 3/100ths of a meter. It's a very small part of the whole. Okay, now this time they tell us we have 8 centimeters. Do I have a full long, a full 10 centimeters? No, so I have 0. How many cubes? I have 8. And can you think of how you'd write this as a decimal in meters? If you said 8/10ths, sorry, woo! If you said 8/10ths of a meter, you could say eh. If you said 8/100ths of a meter, you can say woohoo! Good work. Okay, now this one, they tell us how much of a meter it is, but we need to work backwards. So first I'm going to think, okay, let's read this. This says 3/10ths of a meter. Oh, so if it's 3/10ths of a meter, do I have 3 cubes or 3 longs? 3/10ths, I have 3 longs because each of those is 10 centimeters. And then actually I have nothing in my hundredths place, so I have no cubes. And now look at what we have. We actually would be at 30 centimeters. Okay, now this one, if I had 4 longs, each of those is 10 centimeters, plus 3 more centimeters, that would put me at 43 centimeters. But as a fraction of a meter, I'd have to say, that's how much of a meter? Only 43/100ths of a meter. Okay, one more. This one gets really interesting. If I had 168 centimeters, so this is even bigger than a meter stick. That's quite a lot. Well, 168, how many longs is that? I have 16 longs, right? In my tens place here, I have 16 longs and then 8 more centimeters. So now this is where it gets really interesting. Do I have a whole meter? If you're saying yes, you're correct. I do. I have 1 whole meter and then a little more, 68/100ths of a meter more to be exact. So I'd say 1 and 68/100ths. Finally, I want to do one comparing decimals with you. This is also on page 95. The directions there say work with a partner. Each partner uses base 10 blocks to make 1 length in each pair. Compare the lengths and use greater than, less than, or equal to record the results. I'm confident you can compare these decimals on your own and without the use of base 10 blocks. But to help you, let's first visualize one and do one together with virtual base 10 blocks. Okay, so let's read this decimal on the count of 3. 1, 2, 3, 9/100ths. And then this one, 1, 2, 3, 12/100ths. Let's go look at our base 10 blocks, our virtual ones at least, to help us. So if I want to show 9/100ths, I'm going to need to grab 9 of my cubes. 4, 5, because each cube was 100. Almost there. Okay, and I'm trying to line them up so that I can be able to compare. Great. And then versus 12/100ths, well, then I had 1 entire tenth and 2 more hundredths. So if you consider these images, which is greater? You can pretty clearly see that the 12 hundredths is greater than just 9 hundredths. And you probably could have known that because you're like, they're both hundredths. So 12 hundredths is greater than 9 hundredths. Just like when you compare whole numbers, you know, you look from left to right and see, oh, the zeros are the same, so that doesn't help me. But then this one has a 0 in the tens place, and this one has a 1 in the tens place. So this one is greater. So you just will work your way from left to right to figure out which number is greater. Good luck.